All right, this video is on evaluating logarithms. The thing about logarithms is that the calculator, you see a button on your calculator that says log. Well, that does not allow us to evaluate all logs. That really means log base 10, okay? And then there's another button on your calculator that says ln. Well, that means log base e. So the only two things that we can actually type into a calculator and evaluate are anything with a log base 10 and a log base e. So how in the world do we evaluate something with a log of a different base? There's two ways of doing it. First way is by doing old school math, not using a calculator. So what we're going to do is we're going to set this thing equal to x because we're trying to evaluate what log base 5 of 25 is. Now, once we set it equal to x, we can rewrite it. So rewrite that as an exponential. Take your time and go ahead and rewrite that as an exponential. All right, so we get 5 to the x equals 25. Now, 5 to what power is going to give me 25? If you get confused, just start typing things into the calculator. Like 5 to the first gives you 5, 5 to the second gives you 25, 5 to the third is 125. But we're looking for something that gives me 25, so that means x is going to equal 2. All right, pretty straightforward. Here's another example. Log base, I don't know, 9 of 1 over 81. So the first step, set equal to x. Rewrite it. 9 to the x equals 1 over 81. Now, you have to be careful in this case. So if it's a smaller number to a larger number, you're just going to be looking for an integer value. If it's a number to a fraction, then we know something's going on with the exponent. That means there's going to be a negative value in the exponent because that's the only thing that's going to flip these things over. So a negative value. So 9 to what power now gives me 81? Well, that means 2, so that means this is going to be negative 2. So anytime there's a fraction, that means there's going to be a negative exponent. And then the last little scenario, let's say we have something like that. So first step, set it equal to x. Rewrite it, 9 to the x equals 3. Now we have an integer going to a smaller integer. So this was integer to fraction. We know it's going to be a negative exponent. Here was just small integer to large integer. And that's just the normal problem. Okay, so now we have a large integer to a smaller integer. That means my exponent is going to be a fraction, okay? I know you haven't talked about this a whole lot, but if we're looking at something like the square root of x, that is the same thing as x to the 1/2. The cube root of x is the same thing as x to the 1/3. So that's where we're getting fractions as exponents. So right here, this is going to be 1/2. Now, I know that was a lot of confusing, a lot of rules to go on. So there's an easier way of doing this. And this is called change of base. This always works, okay? Always works. The methods that I showed you over there only work some of the times. This always works. So let's say we have log base 5 of 25. Okay, the way I showed you is rewrite it as an exponential and try to solve. Well, watch this. Using change of base, what we can do is we can rewrite this as log of 25 divided by the log of 5. Now, when I say just log, that means it's a base 10 log. So that means we can actually type this into our calculator now. So we type in log of 25, we hit enter, divided by log of 5, and you end up with an answer of 2. So change of base, log of the top divided by log of the base. The base always goes on bottom. Base, bottom. So let's say we have something like this. Log base 2 of 32. Rewrite it. Log of 32. And then the base goes on the bottom. Base, bottom. So 2 to what power is going to give me 32? and that's going to give me 5. But if you type it in to use change of base, you'll figure out that that's 5. So this works for any problem. So if you try to rewrite it, can't figure out what's going on. So let's say we had the problem log base 9 of 3. Okay, you can't figure out how to do this. Simply type in log of 3 divided by log of 9, and that's going to give you 0.3 repeating, and then that would be your solution, which is 1/3, the same exact thing that we found earlier. All right, so change of base. Base goes on bottom. All right, that's how to evaluate logarithms and also how to do change of base.